Okay, this is chapter 8, and we just write down the significance level alpha and the claim. We leave the sample data till later so it doesn't confuse us. So the significance level is 0.10, and the claim is that the defect rate is less than 3%. If the claim has to do with the mean, it'll say mean in the question. If it has to do with standard deviation, it will say standard deviation in the question. If you're not sure what it is, it's P, because P can be said a million different ways. One way is to say, test the claim that the majority of people favor this, and that doesn't have anything in there that would let you know it's P. But this is a defect rate or a percent, so this is going to translate to P is less than 0.03. And I'm going to write down on the side over here. This is working so well today. I'm so excited. One of the things I sent you guys a sheet of things to memorize, and one of them is that HO is always, always equal to, and H1 is either a greater than, less than, or not equal to. And I'll put this in a different color. If it's a greater than, that indicates a right tail test. If it's a less than, it indicates a left tail test. And if it's not equal to, it indicates a two-tailed test. Okay, so the claim is that P is less than 0.03. So we're going to do step 1 here, HO, and then over here we're going to do H1. And because H1 has the greater than, less than, or not equal to, the claim is going to be in H1. And we need to label that as the claim, and I tend to do that in green. And so when the claim is over here, I call it the magic word, but it's the word that you're going to use in your final conclusion. And when the claim is in H1, the word you're going to use in your final conclusion is support. And that's on the back of the critical value method of hypothesis testing handout. There's a whole section on wording of final conclusions. Okay, so we know what H1 is, and HO, according to over there, is always equal to. So it's going to be P is equal to 0.03. And now we have to draw the picture. So you need to go to your formula card. It's the first test statistic in the Chapter 8 box, and it says proportion next to it, and it starts with the letter Z. So this is going to be a Z distribution, or the standard normal distribution, which looks like that. And because H1 says less than, it's going to be a left-tailed test. So I'm going to shade this region in. And then I'm going to draw a line here. And if you get anything to the left of this line, didn't leave myself a lot of room, you're going to say reject HO. And if you get something on the other side of this line, you're going to say fail to reject HO. And make sure you put the HO there or you do not get credit for it. Okay, step 2 is your significance level, your alpha, which in this case is 0.10. We do not divide by 2 because it's a one-tailed test. Step 3. We need to find Z sub 0.10. And in Chapter 7, we had a little cheat sheet that we could use for that. In Chapter 8, we can't use that cheat sheet, but we have a different cheat sheet that we can use, and the different cheat sheet is the t-table. I know we need a Z number, but we can use the t-table to find that Z number. So get your t-table out. At the top of the t-table, it says area in one tail, and then it says area in two tails. we always, always, always use only the area in one tail. We will never look at the area in two tails. So we go to area in one tail, we find point 10, and then we go all the way down to the bottom where it says large. The author used to have the letter Z in parentheses next to the word large, but he stopped doing that a couple of editions ago. But that's what we're going to do. So you find point 10 at the top, and you go all the way down to the bottom, and it says 1.282, but Z numbers have to be 2 decimal places long, so we're just going to call it 1.28. If you called it 1.282 on the final, I would be fine with it. In fact, the graduate students who write the Student Solutions Manual often use those numbers at the bottom there and go to 3 decimal places, so it doesn't matter to me. Okay, so when I go over to the picture and I put 1.28 here, something about that should bother you, because in the Z distribution, 0 is in the middle. So any numbers to the left of center are negative numbers. So you have to remember on a left tail test to make that number negative. And so the critical value is negative 1.28. And you don't have to put CV. If you draw the picture, that's fine. I also write a sentence that says, reject HO if Z turns out to be less than negative 1.28. And notice that the sign in H1 is less than, so the sign in that sentence is also less than. Step 4 is the test statistic. Z is equal to P hat minus P over square root P times Q over N. And now and only now do we need the sample information. And I'm going to write that over here, I think. Sample information. It says, in a random sample of 85 items, so N is 85. And it says the defect rate is 1.9%, which of course will become 0.019. And that is your P hat. Everything's going uphill. I don't know why, but it is. Anyway, if you go back to problem 3A, I didn't give you P hat there. I gave you X and N, and then you had to calculate P hat. So on this problem on the final, sometimes you'll be given P hat, and sometimes you'll have to calculate P hat, depending on which version of the final you end up with. If you're given a number that is a decimal, then you have P hat. If you're given 2 whole numbers, then you have X and N, and you're going to put those 2 numbers together to get your decimal number. Okay, so P hat is 0.019 minus P. And again, if you have your handout in front of you, the way a hypothesis test works is that we always assume that HO is true. And then at the end of the test, we either reject it or don't reject it. So for step 4, you go back up to the HO, and that's the value that we're going to use for P. So P is going to be 0.03, and I'm going to add a 0 on that just because I like my decimals to be the same length. Okay, so I've got sample numbers over here. Now let me put down my population numbers. We know that P is equal to 0.03. Q is how much money you would need to get to $1, and so that would be 0.97. Or it's 1 minus P. But I just like to think of them as how much you need to get to $1. Okay, and then in the denominator down here, I'm not going to put the extra 0. P is 0.03, and don't close the parentheses inside a square root. It generally messes it up. calculators are different now, but it's just better not to do that. So I'm going to put 0.03 times 0.97, and that whole thing is going to be divided by 85. So I have a beginning parentheses, and when I start the square root, and I don't close the parentheses until I get to the end of the square root. You're going to do this on your calculator in one step, not 2 steps or 3 steps or 4 steps, and you cannot round off anywhere in the middle of the calculation. So in order to accomplish that, we're going to put parentheses around the numerator. And we get parentheses 0.019 minus 0.03. Oh, if you want, you don't have to. Close parentheses, divided by square root. And you should get a beginning parentheses when you hit the square root if you don't put one in. And then it's 0.03 times 0.97 divided by 85, close parentheses, and enter. And the answer comes out to be negative 0.59. And then step 5, initial conclusion. Okay, so you look at the graph, and negative 0.59 would be over here. It would not be in the reject region. So our initial conclusion is fail to reject HO. And you do get the 5 steps. And so in step 5, it says form an initial conclusion about HO and then a final conclusion about the claim. If we had rejected HO, then we would support the claim. But since we did not reject HO, it might still be true. So we fail to support the claim. But I left the out because I didn't have a lot of room. Okay, comment. On your final exam, problems 4A and 4B are not going to be exactly like the practice. In other words, this is a left tail test. The one on the final is not going, for 4A anyway, is not going to be a left tail test. It's either going to be a right tail test or a 2-tail test. So you have to be aware of the different types of tests. It's just for an A and B that I changed. The rest of them will be exactly like the practice. But for A and B will be different, so you cannot just give me back what I said. And again, the wording of the final conclusion you can find on the back of the critical value method of hypothesis testing. Okay, wow, that's a long time. Okay, now we're going to, oops, I got to push the button here. Okay, now we're going to go on to part B. And again, we're only going to write down the significance level alpha and the claim. And so let's see what it says. It says, in a study of blood pressure levels, a sample of 75 randomly selected women aged 25 to 34 results in a mean systolic value of 116.7 and a standard deviation of 12.5. Not going to write that down. At the 0.05 level of significance, so there's my alpha, test the claim that this sample comes from a population with a mean equal to 120. So the first thing that we're going to do is translate from English to math. And remember, when you are writing your claim, you have to use population symbols. Very, very important. When writing your claim, you must use population symbols. So the population mean is called mu equal to 120. Okay, now we start the test. HO, as we showed on the previous screen, is always equal to. So the claim this time is going to be in HO. So we are going to label it claim, and the word that we use in our final conclusion here will be reject. And then to help remember, I put /ditto. You're not going to use the word ditto, but what I'm trying to say is that whatever you say about HO, you're going to say the exact same thing about the claim, because in this instance, HO is the claim. So you're going to say the same thing twice. For H1, again, if you go to the critical value of hypothesis testing, it says if you don't get a less than, greater than, or not equal to in your claim, which we didn't get, then you have to take the opposite of your claim. And here our claim is mu is equal to 120. So the opposite of that is that mu is not equal to 120. Okay, now when you go to the formula card, this is the Chapter 8 box, which is on the second page. And for mean, there are two formulas, one that says sigma unknown and the other that says sigma known. We always, always, always use unknown. Same thing in Chapter 7. We always, always, always use unknown. So we notice that that formula starts with the letter T. So when I draw my picture, it's a T distribution, which looks an awful lot like a Z distribution. And because the sign in H1 is not equal to, that lets me know that we have a two-tailed test. So we're going to shade in two tails. And that also means that we're going to have two rejection regions. One rejection region is to the right. I'm just going to go with reg, which means reject HO. And then on this side, it's the same thing, reject HO. And the middle is fail to reject HO, which I'm going to abbreviate to FTR, HO. Okay, so that's step one. Step one is to state HO, state H1, label the claim, and draw the picture. And please make sure you do the steps in order on the final. Don't start out with step 4. Doesn't make any sense to do that. You do, and you'll have all the 5 steps there so you can follow that. Okay, step 2. Oops, wrong marker. Here we go. Step 2, alpha. And alpha is 0.05. But because this is a two-tailed test, we have to divide alpha by 2 to get 0.025. You only divide by 2 when you have a two-tailed test. In the last problem, we didn't need the sample data until step 4, but in this one, we need it for step 3. So I'm going to write down the sample data over here. And it says 75 randomly selected. So n is 75, which means our degrees of freedom is 74. The formula for degrees of freedom is n minus 1. And it also says that the mean is 116.7, but this is the sample mean. We've already used the population mean mu in our HO, so the sample mean is x bar. And it also says that the standard deviation is 12.5, and that is the sample standard deviation, which is S. Okay, so we know we're going to the T table because the formula starts with the letter T. So we want the T table sub 0.025. Let me erase that 5. I don't like the way it looks. 025, comma, and degrees of freedom is 74. Now the T table probably won't have a 74, so we're going to pick the one that is the closest, which in all likelihood is going to be 75. So Oh, there is no 75. Okay, there's 70 and there's 80, so we're going to go with 70 because that's the closest one. So that value is 1.994. But when you go to the picture over here, you're going to notice that you're going to have both a positive value and also a negative value. That's why drawing the picture is so important. Okay, I'm going to put critical value equals plus or minus 1.994. You don't have to do that. I overkill a little bit. If you draw the picture, then I can see that you have a plus or minus, or if you write the sentence. And the sentence would be, reject HO if T turns out to be less than the negative number, or if T is greater than the positive number. Step 4 is the test statistic, which is X bar. I don't see the bar on the sheet here, but anyway, it's X bar minus mu over S divided by the square root of n. So X bar is 116.7. To get mu, remember you get your population numbers from HO. So mu is 120. I add a 0.0 for no reason except that I like them to have the same number of decimal places, divided by S, which is 12.5, divided by, oh, it's not 85, it's 75. Excuse me, 85 was the last one. Okay, so it's divided by 75. Okay, I'll go over this again. And on this one, again, you want to do the calculation in one step. So you're going to put parentheses around the numerator and parentheses around the denominator. So parentheses 116.7 minus 120, close parentheses, divided by new parentheses 12.5 divided by square root 75. And that should come out to be negative 2.286. Okay, step 5, initial conclusion. So now we're going to compare the test statistic with the picture. So negative 2.286 is more negative than negative 1.994. So in this case, we are going to reject HO. Final conclusion, remember we said at the beginning that HO is the claim, and I call this ditto because whatever you say about HO, you're going to say the same thing about the claim. So reject HO, reject claim. Okay. And again, remember this one is going to be different on the final. This is a two-tailed. It's either going to be a right-tailed or a left-tailed, so be prepared for the difference. Okay, now we're going to go on to part C as soon as I do that. Okay, part C. Okay, and this one talks about different waiting lines in banks. In the old days, you would get in a line behind one teller, and everybody would line up behind the tellers, kind of like the grocery store. So some lines would go faster and some lines would go slower. But now, of course, in banks, they just have a single waiting line, and you make your way up to the front, and the next available teller takes you. So with several different waiting lines, a bank finds that the standard deviation of waiting times is 3.2 minutes. So that's under the old system. The bank experiments with a single waiting line and finds that for a random sample of 25 customers, the waiting times have a standard deviation of 0.3. And again, we're not writing any of that down yet. We just need the significance level alpha and the claim. And then it says at the 0.05 significance level, test the bank manager's claim that the single line produces a different, and I'm just going to go SD for standard deviation. So in the past, it was 3.2 under the old system. They told us that in the first sentence. Okay, so we have to translate our claim from English to math, and this is standard deviation. And the symbol we use, the population symbol for standard deviation, is sigma, and different means not equal to what it was in the past, which was 3.2. Okay. So we're going to have to find our HO and our H1, and since the claim is a not equal to, that will go into H1. And that is the claim, so we're going to label it as the claim. And the word that we use in the final conclusion when the claim is in H1 is support. And then HO is always, always, always equal to. So its sigma is equal to 3.2. When you go to the formula card in the Chapter 8 box, the very last formula is for standard deviation. And that formula starts with chi-squared. Remember that you got a chi-squared cheat sheet that you will have during the final exam. But let's draw the picture of the chi-squared. It's not like the z or the t. It's not symmetric, and 0 is not in the middle. It is restricted to the first quadrant, which means everything is positive, and it is skewed. And because this is not equal to, this is a two-tailed test. So it's going to look like that. And let me see if I want to make this a little bit shorter up there. So again, we're going to have two rejection regions. And now these, from this point on, will be the same as the practice. It's only for A and B that are going to be different. So yours will be a two-tailed. So we have reject HO over here, and we have a little reject HO there, and the middle is fail to reject HO. See if I can get that a little bit more legible. FTR-HO. Okay. If you take out your chi-squared cheat sheet, and I'll do this in a different color. I'm going to go blue, because we will be erasing this eventually. The cheat sheet tells you for the right side, you should use alpha divided by 2, and for the left side, you should use 1 minus alpha divided by 2. So this part is the same as part number 1, part C. Okay, so step 2, alpha is equal to 0.05. We do have to divide it by 2 and get 0.025, and then we need 1 minus 0.025, which is 0.975. So I'm going to go over here and just write down, for the right side, we're going to use 0.025, and for the left side, we're going to be using 0.975. Okay. Step 0.03. Now we're going to need some sample data. And I can fit that over here, I think, underneath this. And it says that the bank experiments with a single weighting line and finds it for a random sample of 25. So that's my N, which tells me then that degrees of freedom is going to be 24. And it said the waiting times have a standard deviation of 0.3. That is sample standard deviation, so that is S. Okay, so let's do the left side first. The left side is 0.975, comma 24. So you're going to go to the chi-squared table, 0.975, 24, and it says 12.401. So that is your left critical value. And then for the right side, chi-squared sub 0.025, comma 24, and go to the chi-squared table. 02524 turns out to be 39.364. So this is 39.364. And then we can say that we are going to reject HO if chi-squared turns out to be less than 12.401, or if chi-squared is greater than 39.364. Okay, step 4 is the test statistic. Chi-squared, the last one in the chapter 8 box. It's n minus 1 times s squared over sigma squared. So that's 25 minus 1. S is 0.3 squared. And then in the denominator, sigma is the population number. And again, we go back to HO. So it's going to be 3.2 squared. And that's a pretty straightforward one. You shouldn't have any problem doing that one on your calculator. And that one turns out to be 0.211. So looking, well, let's just write down step 5 here. Step 5, initial conclusion. And now we're comparing the test statistic to the critical value. And 0.211 is a small number that would fit in there. And so our initial conclusion is to reject HO, and the final conclusion. So when you reject HO, it's gone, you've thrown it out, it's no good. The only thing left standing is the claim. So we can say that the data support the claim. Okay, so that takes care of the problems from Chapter 8. And now we'll go on to Chapter 9. Okay, Chapter 9 is different from Chapter 8. So I'm going to write this information down. Randomly selected men and women are given tests of memory, and the results are given below. So this is part D. At the 0.05 significance level, test the claim that the populations of men and women have equal means. equal means. Okay, so I'm going to write the information down over here. I think we can do it. So for the men, n is equal to 40. X bar is 79.8, and S is 6.8. For the women, N is equal to 50. X bar is 81.2, and S is 8.4. Holy crap. Something went wrong there. I'm going to have to fix that one. That's hysterical. Wow, everything was going so well. I don't know what just went wrong there, but something went crazy. All right, we're going to try it one more time. Turn this around so I can watch it and see if it goes nuts before I turn around at it. Okay, so this is problem 4D. The significance level was 0.05, and the claim is that, what the heck is going on here? Okay, I'm going to erase that and try again. Oh, I was on such a roll. Is it the whole thing? All right, what the heck is going on? We were doing so well. D. Alpha is 0.05. Just not sure why we're not getting this to go now. And the claim, okay, is that they have the same mean. All right, we're going to stick with this now. Get rid of a little bit of extraneous stuff here, and I think we're okay. Okay, so let me try the information again. Men. N is equal to 40. X bar is equal to 79.8. And S is equal to 6.8. It's kind of far apart, so I'll make the dot a little bigger. Okay, and then for the women, N, isn't that weird? But I'm catching, ooh, just when I move the marker. All right. Okay, we'll come back up here and try that. Wow. N is equal to 50. X bar is 81.2. Holy Toledo. I'm not frustrated. This is wonderful. We're going to try one more time. X bar equal to 81.2. How freaking weird is this? I gotta find that line to erase it, which is difficult. Oh, lordy, lordy, lordy. I don't know why. This is so weird. I apologize, guys, but it's just bizarre. x bar is equal to 81.2. All right. Never mind. I'm not going to write the data down. You guys have it on your sheet because this is just too frustrating. And if it doesn't work this time, I'm just going to... All right. I'm frustrated. I'm done. I'm going to stop now because this is driving me crazy, and I will try again on Thursday. But at least I got the Chapter 8 up there, and then I'll do D, E, F, and G on Thursday. I apologize, but this is crazy. Okay, bye.